In problems 53 through 56, we have these geometric solids. And in each case, there are three parts that make up the equation for the volume of the solid. And we're given two, and we need to solve for the third. So first of all, let's review a little bit about geometric solids. The first one, we'll call it, but it is called a cylinder. The second, number 54, is a rectangular prism. The third is a cone, and the fourth is a pyramid. Now, rectangular solids, although each of them has a different formula for their volumes, there is a sort of simple way to remember the volumes, the formulas for the volumes of these solids, and that is, at least for the cylinder and the prism, we would say that the formula for volume is capital B, which is the area of the base times the height. So remember that capital B is the area of the base. And we'll distinguish that from little b, which is used in a triangle, like the area of a triangle is 1/2 BH. We'll use a little b there because that refers to the length of the base of a triangle. Here we're talking about the area of a base. Alright, now we're not going to get into the specific formulas for each area of a base. We're either going to be given the area of the base, or we're going to find the entire area of the base. Now with the cone and the pyramid, they are related to, the cone is related to the cylinder, the pyramid is related to the rectangular prism. By the formula, the volume is 1/3 of the area of the base times the height. So all we need for these then is, let's start with number 53. We have a basic formula. The volume of the cylinder is equal to the area of the base times the height. We're going to be given 2, and we're going to have to solve for 1. Here we're given the volume, which is 84 pi. We're not given the base, but we are told that the height is 7. So the volume is equal to the area of the base times the height. So 84 pi is equal to B, capital B, times 7. And to solve that, we'd only have to divide both sides by 7. And we would end up with B is equal to 12 pi. It's very important to note that the pi doesn't cancel out. We divide 84 by 7 and we get 12, and pi is still there. So the area would be 12 pi inches squared. Remember, we have three types of quantities here. We have a height, and let's just mention here that height, its units of measure are linear. That means it doesn't have an exponent. We have the area of the base, its units of measure are square. And we have volume, and its units of measure are cubic. Alright, so that's just to remember here, depending on which value we're trying to solve for, they will have different units of measure. Since we solve for the area of the base in problem 53, it has square units, and so it's 12 pi inches squared. We'll go on to number 54, which is the rectangular prism. Here we're given the area of the base, but not the height. So again, we start with our basic formula. Volume is equal to base times height. And we know that the volume is 1323. The area of the base is 147, and the unknown is h, which we solve by dividing both sides by 147. And we end up with h is equal to 9, Here, because height is a linear quantity, its units will simply be centimeters. We'll go on to number 55. So for number 55, this time our formula is 1/3 capital B H, and we're given that the volume is 15 pi meters cubed. We're told that the height is 5, but we're not told the area of the base. So I'll put the 5 next to the 1/3 and times the area of the base. So we have 15 pi is equal to, and if we multiply 1/3 times 5, we get 5/3 times capital B. I'm going to scroll this down just a little bit. Now, remember how we solve when we have a fraction in front of our variable. We're going to multiply both sides by the reciprocal of 5/3, which would be 3/5. That's the easy way to do it. Then if we cross cancel, 5 divided by 15 is 3. 3 times 3 is 9, and we end up with 9 pi is equal to capital B, or B is equal to 9 pi. Since this is the area of the base, our units have to be square units for area, and that would be 9 pi meters squared. We have to be really careful with our units of measure in these cases. All right, we're going to go on to the next problem, which is number 56. So for number 56, again, it's a pyramid which uses the form volume is 1/3 of the area of the base times the height. Here we're given the volume, 35. We're given the area of the base, which is 30, and we're not told what the height is. So you can see that 1/3 of 30 is 10. 35 is equal to 10h. We divide both sides by 10. And so the height would be 35 divided by 10 is 3.5. Here we have a height, so the units of measure are linear, and since we're working with feet, the height would simply be 3.5 feet. And that's going to do it for problem number 53 through 56.